morning, everyone. My name is Zach, and I'm part of the XBlock team. Here at XBlock, we've recognized the benefits of blockchain-based fog computing. We aim to bring these features to the mainstream. And today, we have one of our team members, Robert, who will give a more in-depth look about our product.
Might as well get started. So I'm sure a lot of you in the room have heard about fog computing, but for those of you who haven't, the idea is that cloud computing is basically running the entire internet right now. It is all of the apps, all the services, everything you use on the internet is run off some server somewhere out in the cloud. Now, what we want to do is bring that down to a lighter layer. Bring it down, spread it out, distribute it, and that is technically fog computing. That was a term coined by Cisco in the 90s, and it hasn't really come to fruition, but now that blockchain technology has matured to the point where we can bring this out, it's really time for fog computing to come to the mainstream. Now, here we are. Now, we are realizing the dream of fog computing. I've heard a lot of people say that fog computing is the future. However, that is really a difficult task. There's a lot of things that have to go into a network to create a fully fleshed out application to be used by developers. There's been steps in the right direction. There's been developments, but XBlock, we are really trying to finalize that, bring it together, put it out on the market for people to use. Now, the first step in that process would be to achieve a high enough transactions per second number. Now, I know Bitcoin is somewhere at 3 to 7. We need to have a similar latency to traditional internet technologies if we're going to truly have some sort of usable infrastructure on the internet. We're going to be looking at clients, enterprise clients, huge customers that are used to quick interactions, huge amounts of power, and that is not going to happen in the current state of blockchain tech. So we have had a few ideas to get these numbers up, to get this powerful enough to really come together in and be usable. The first step was our Byzantine Agreement Protocol, which instead of having everyone compete for the same final consensus, we have a verified random function that allows every device on the network to vote for a final machine to submit the final consensus while maintaining the same level of security as a traditional platform. Now, I have a few graphs here. There's not a whole lot of information you can get from them because we are just this much faster than Bitcoin. We have achieved 125 times the throughput of Bitcoin, and we have reduced the latency for confirmed transactions from 1 hour, 3,600 seconds, down to sub 20 seconds. Those numbers have been confirmed in networks of more than 500,000 people. And we've achieved between 5,000 and 10,000 TPS in tests, as opposed to Bitcoin with 3 to 7. Now, we need to create a secure network that can continue to have the same level of security as traditional blockchain technologies, because anything less than that is just unacceptable. We need to have, if it's going to be on the blockchain, it needs to be as secure as everything else on the blockchain. So to mitigate pseudonym attacks, we have the consensus node send a one-way transaction. It calculates it. The chain is waiting for this based on an algorithm, and it sends it one way, so there's no way for a computer to figure out which one's going to send it to have a man-in-the-middle attack or any other sort of targeted attack towards that one computer. We also have an honesty ranking system that is based on the number of confirmed transactions from that node in the past, and also the amount of currency in that user's wallet. So to keep them honest, to make sure that everything is submitted properly every time, the random function will only choose people from a pool of verified honest users. And because of that, we are using an amount of currency in their wallet. That means in terms of Bitcoin, you have 1/3 of users. They rate their fault tolerance in terms of how many users need to be compromised before you start to see issues. In their case, it is 1/3 of the users. In our network, it would have to be 1/3 of the total amount of tokens. So if you were to try to set up a bot attack, millions and millions of bots, you would have to somehow have those bots control 1/3 of the total amount of tokens in the network, which would be nearly impossible and too time-consuming to worry about. Now, the X adapter is our other breakthrough technology, which means that we can seamlessly integrate with other chains, with other main chains, Ethereum, EOS, and we can send these jobs over Ethereum and EOS to further reduce the load, to reduce the amount of work that the computers in our network have to do. And that means that more power is available to these computers to work for the jobs in the actual fog computing network. The less work that they're doing to reach consensus means the more CPU cycles they have left over to work for the fog computing network. Now, that means the more devices that can contribute means the more power we have left over. Now, our eventual goal is to become the first turnkey infrastructure as a service platform on the blockchain. So this means for developers, you can log in using a console just like you would for Google Cloud, Amazon Web Services. You select the amount of power you want, the amount of storage you want, and you are able to use it in the exact same way as a traditional cloud computing software, only you have the benefits of it being on the blockchain. So the main benefit of this being with us is that developers can seamlessly integrate with their existing projects because our chain is completely interactive with existing chains. So if people are used to developing on other chains, it is much easier for them to code in a language that they know, and their projects can interact seamlessly with their projects on our chain. Now, if you're a corporation and you're looking to get into our network, you can use your existing servers. You have rack space, you have servers, you have your own cloud that you can dedicate to our ecosystem. You put that on the blockchain, and other people use your time and your resources during your downtime, so that when it comes time for you when you need the power, you can call out to our network and receive infinite power. So as an example, the federal student aid network in the United States is, it's for students. So it's only really used when the school season is starting. So it's used twice a year. It is used very heavily because almost every student in the entire United States is using it. And the rest of the year, these huge warehouses of servers are sitting idle. So in this particular case, these servers would be running all the time, and they would be computing for other devices, and they would be generating tokens. They would be generating currency that can then be used during the high season to have an infinitely scalable network of computers and of computing power. And I would like to invite investors to be the first step in the truly, that's time, but to be the first step in truly realizing the goals of blockchain as a whole, and create something real, create a thing that can be really used in a mainstream way by people that need it, just like traditional cloud computing services. And I would like to welcome Zach for some closing remarks.
Once again, Robert, I want to thank you for your wonderful presentation of our product. And on behalf of the XBlock team, we would like to welcome everyone to Blockchain 4.0.